Today we're going to look at solving systems of equations using the substitution method, and for these two examples we're going to look where one equation is y equals but the other equation is not. And you can clearly see in my example here, one equation is y equals or slope-intercept form, and one equation is in standard form where both x and y are on the same side. Provides a little different challenge than yesterday's work. However, the process is the same because I recognize that that's equal to, y is equal to, what I'm going to do is I'm just going to take this expression and I'm going to plug it in anywhere I see a y. So in my second equation, I'm going to plug it in for the y. Now what that gives me is 2x plus 4 parentheses, and here's where I'm going to put my negative 8x. Make that equal to 0. Now I have one equation with one variable. So instead of having two equations with two variables, now I'm down to one equation with one variable, and now I can solve. So this is multiplication. That's going to be 2x minus 32x equals 0. Since these two happen to both be like terms, I can subtract those and make that negative 30x equals 0. And since I'm trying to get x by itself, at this point I'm going to divide both sides by negative 30. And I find out that x is equal to, well, let's see, 0 divided by negative 30 is 0. So for an answer, my x value is 0. And there's nothing wrong with that. Once you know your x value, just like we did yesterday, I can take the x value and I can plug it into either one of these equations. Now in this case, which equation makes more sense? Probably this one, since it's already equal to y. So I'm going to plug that into the top equation, y equals negative 8 times 0. And of course I know negative 8 times 0 is in fact 0. So in this case I ended up getting a 0 for both my x and my y. And there's nothing wrong with that, because if I graph these on Desmos, I will see that it does indeed cross at 0, 0. Now, recognize that in order to graph this on Desmos, that second equation, I had to solve it first for y equals, which was one reason why substitution might have been easier in this case. So our solution is x equals 0 and y equals 0. Okay, a second example to look at. Again, I've got two equations. Again, one of them is in standard form and one of them is in y equals form, which actually makes it really easy to use substitution. So I'm going to take this one that's in y equals form, and I recognize that I can take this anytime that there's a y, I can substitute it with 2x. So I'm going to take this expression and I'm going to plug it in up here wherever the y is. So that's going to give me 6x plus 7 times, here's where I plug in that expression, 2x, make that equal to 20. Now again, one equation and one variable I can solve. So 7 times 2x is 14x. Here's my 6x. I do have like terms here, so I'll put those together. 6x and 14x is 20x. And if I divide both sides by this 20 here, I'll end up with x equals 1. So my x value is going to be 1. Now, to find the y value, I can take this x value and I can plug it into either one of these equations. Now, which equation would be easier? Well, it appears that the bottom equation would be easier since it's already equal to y. So I'm going to plug in the 1 in right here. So that's 2 times 1. And clearly you can see that y will give you 2. So it appears that my solution is going to be x equals 1, y equals 2. Let's check that on Desmos. As you can see on Desmos, the intersection of these 2 points is 1, 2, x equals 1, y equals 2. But also recognize that in order to graph that first equation up here, I would first have had to solve it for y equals, which of course makes its own challenging part. which is why substitution would have been better in this method.